Hi everyone, my name is Suyen and we are from Team 1. The article that we have selected is DeepSeek R1, Incentivizing Reasoning Capability in LLMs via Reinforcement Learning. This is our group name and our group members' names. In this article, we will explore how DeepSeek's reinforcement learning approach unlocks reasoning LLMs without supervised fine-tuning. In recent years, large language models (LLMs) have been emerging rapidly, gradually narrowing the gap and evolving closer to artificial general intelligence. Post-training, such as reinforcement learning, is one of the critical developments in LLMs. It enhances the reasoning accuracy, aligns with social values, adapts to user preference with relatively minimal computational resources. OpenAI's O1 series is the first to introduce inference time scaling by increasing the length of chain of thought, which is a significant improvement in reasoning. However, the general reasoning performance remained a challenge for the research community. The researchers have explored various approaches, including process-based reward models, reinforcement learning, and search algorithms such as Monte Carlo tree search, and etc. None of the approaches can match with OpenAI's O1 series. Hence, DeepSeek is motivated to explore the potential of LLMs to develop reasoning capabilities without any supervised data, but based on pure RL process. The results show super performance on reasoning benchmark, matching the performance of OpenAI O10912. And this is a breakthrough in LLM's reasoning, and it has further motivated DeepSeek to explore distillation from DeepSeek R1 to smaller dense models. It has demonstrated that the results are comparable to O1 Mini, and it benefits the research community. The challenges faced by DeepSeek R10 is poor readability and language mixing issues. Another challenge is balancing autonomous reasoning and human preferences, but both have been resolved. In summary, both DeepSeek R10 and DeepSeek R1 trained via large-scale reinforcement learning without supervised fine-tuning have achieved exceptional reasoning capabilities. And the open-source DeepSeek R1 as well as its API has provided greater opportunities to the research community to distill better, smaller models in the future. Thank you.
Hi everyone, I'm Peng Xiangyu, and now we're going to talk about the approaches applied to DeepSeek models. I'm going to focus on DeepSeek R10 model, where pure reinforcement learning is applied directly to the base model without the use of supervised fine-tuning methods. They utilize group relative policy optimization algorithm for the reinforcement learning to save the training costs. Because in traditional RL algorithm, the policy model is typically the same size as critic model, which means that the training cost will be doubled. However, the GRPO only estimates the reward baseline using the relative ranking scores between a set of answers, and it always chooses the answer with the highest score. So it saves the training costs compared to the traditional reinforcement learning algorithm. To train the model, they adopted rule-based reward system that consists of two types of rewards. One is accuracy reward that evaluates whether the response is correct, and another is the format reward that enforces the model to put its thinking process between formulated tags. The training template is like this. The reasoning process is placed between the think tags and the answer is placed between the answer tags. This template requires the model to first produce a reasoning process and then followed by the final answer. However, this kind of constraint is limited so that it can avoid any content-specific biases and only focus on whether the answer itself is good enough. From this graph, we can see that the accuracy is increasing as the steps of training are increasing. And by comparing the polyline with the dashed line, we can see that the zero model actually outperforms the OpenAI's O1 model. This table is the comparison of zero model and OpenAI's O1 models on reasoning-related benchmarks, and we can see that the model can learn and generalize effectively through only reinforcement learning. In addition, the performance of the zero model can be enhanced through the application of majority voting. From this graph, we can see that as the model has been trained for more times, the average response length is also increasing, indicating that the model can think deeper and solve more complex problems. There is also an aha moment occurs in the intermediate version of the model, where the model rethinks its solution just like a human. This is a very crucial finding showing that the reinforcement learning has a very large potential in unlocking the new levels of intelligence in artificial systems. However, there are also some limitations in the zero model, like poor readability and language mixing. So to enhance the model, we're going to explore the DeepSeek R1 in the next section, which will be introduced by Jinhua. Thank you.
Thank you, Sherry. I'm Jinhua. So, how can we make large language models not only give answers but give clearly explained and easy to read ones? This is exactly what DeepSeek R1 aims to show. It uses four-stage training pipelines. The first two focus on reasoning abilities, while the last two focus on enhancing the generalization and alignment with the user preference. Now, let's look at the first stage, cold start fine-tuning. Reinforcement learning is unstable at the start. This is so-called cold start problem. So DeepSeek R1 first warms up the model with a small amount of high-quality long-term thought data. Here, the long-term thought means that the model reasons step by step like a human. These COT data are generated by prompting DeepSeek R1 0 and then manually polished. Now, let's move on to stage 2, reinforcement learning for reasoning. We continue training you the same large-scale RA setup as at 1.0, focused on math, coding, and logic. During the training process, we found there were mixed language outputs in COT response. To fix this, we introduced a language consistency reward, which gives higher scores if most of the COTs is the target language. Although ablation studies show that this slightly reduced accuracy, it makes answer more readable and user-friendly. So the final reward evaluates whether the reasoning is correct and whether the language is clean and consistent. It helps improve both accuracy and readability. After the previous reinforcement learning stage has converged, we use its checkpoint to collect a new round of supervised fine-tuning data. To extend models' abilities beyond reasoning to general tasks like writing, Q&A, and translation, we collect two types of data. For reasoning tasks, we use a rejection sampling and reward models as a judge to select high-quality outputs, and then filter out messy or multilingual response. For non-reasoning data, we reuse and augment part of DeepSeek V3 SFT data. Together, we collect a total of 800,000 samples, which are used to fine-tune DeepSeek V3-based model over 2 epochs. To make the model not just accurate but also helpful and safe, aligned with human preference, we introduced a second round of reinforcement learning. At this stage, we introduced two important reward dimensions. Helpfulness focuses on whether the final output is actually useful to the user, and harmlessness check if the whole response contains risks, bias, or harmful content. Beyond the four stages, we also explored an extra contribution, knowledge distillation. We used the powerful DeepSeek R1 as a teacher and transfer its reasoning ability to smaller models like Qianwen and Llama. No reinforcement learning is used at all. We just use 800,000 high-quality samples generated by R1 to fine-tune the small models via SFT, letting them mimic R1's reasoning style and output format. It turns out that even without RL, SFT-based distillation enables small models to perform strong interpretable reasonings.
Hi everyone, my name is Tan Xin Pei. Now I'll be talking about the experiment, and before we go into model evaluation, I will talk about the benchmark and baseline in this experiment. So benchmark, there will be total 20 plus of benchmark used to compare different models and do evaluation. And while for baseline, there will be total 5 models serve as the baseline model to do a comparison with our model, which is the DeepSeek R1 model. For distillation, QWQ is added into the comparison as well. Next, we go to DeepSeek R1 evaluation, which mainly focus on English, code, math, and also Chinese. As we can see in the red box, it actually showing us a superior performance of DeepSeek R1 when compared to DeepSeek V3. This is due to the increased accuracy in the STEM-related question that are being enhanced by the deep reinforcement learning. So as we look deep into each benchmark, for example, the frames, we can see that DeepSeek R1 actually have a high score in this frame benchmark, which indicates that DeepSeek R1 are actually having a strong document analysis capabilities. While for the last two benchmark in English, DeepSeek have a high marks as well, which means that it is performed well in the writing task and open domain question answering task. Next, we go to the coding benchmark. DeepSeek R1 actually having a comparable performance on most of the benchmark except for the last benchmark, which have a low score. While for math tasks, DeepSeek R1 have surpassed all the models and have a similar performance to the OpenAI 011217. Next, we come to the distill model evaluation. As we can see from the red box under the distillation, the model is being produced in different version. And as we can see from the DeepSeek R114B, it relatively good performance when compared to QWQ on all the benchmark evaluation. Well, next for the R1 32B and 70B, it actually outperformed the OpenAI O1 mini model on most of the tasks except for the code freaks. And this result actually proves to us that distillation is a method that is effectively transfer reasoning ability from the large to small models. And by applying reinforcement learning to this distilled model, it can bring further improvement in our future work. That's all from me. Now I pass the time for next person.
Hello guys, I'm AIT2209094 Xie Yuxuan. Now, let's zoom in some topics worth discussing in DeepSeek R1. The team explains how they use deep reinforcement learning to spark reasoning in large language models, pits distillation head-to-head against RL, and openly shares what went sideways. These insights provide us with valuable experience for gaining a deeper understanding of its breakthroughs. First, according to their findings, distillation crushes same-size RL. It turns heavyweight knowledge into a lighter, sharper tool. The experiment reports that the distilled model outperformed the RL-only model on math, code, and GPQA test. RL was ambitious, but it faced steep cost and rewards tuning issues. The researchers advised peers to favor distillation for quick gains and save large-scale RL for future, more powerful base models. The team also tells us what didn't work. The first one was the process reward model. They try to give us more reward for every step in the reasoning process, but it was slow to label those steps. As a result, the model learned to hack the reward. The second attempt was Monte Carlo tree search. It usually works in game like Go, but for text, the search space becomes very large. Without a strong value model, it is just slow and costly. So what we get from this experience? Use RL on a big model to discover new reasoning skills. After that, distill the knowledge into lighter models that run faster and cheaper. From researchers' unsuccessful attempts, PRM or MCTS might still be useful if we only use them to re-rank outputs, not to train from scratch. Last but not least, we should keep an eye on our compute cost, because efficiency matters as much as accuracy.
Okay, thank you. I'm Wenken. Next, I will talk about the conclusion and the limitations. So first, DeepSeek R1 demonstrates that a large language model can discover a chain of thought reasoning entirely through a reinforcement learning without any supervised chain of thought trainings. On the AMS-MATS benchmarks, the accuracy rotated from around 15% to nearly 80%. That surge underscores how pure RL alone can unlock a coherence and the multiple steps of reasoning. And second, the model follows a very clever multiple step pipelines. It begins with a small and QRET supervised fine-tuning, then alternates between a reasoning focused RL and a bot supervised tuning. And finally, a closing RL pass refines everything, balancing the rapid scan output, clarity, and the stability. In short, it's blend guidance learning with autonomous explorations. Third, and the most exciting, the emergence reasoning is not trapped in a giant model, and those skills are successfully distilled into a very small versions from 1.5 billion up to 70 billion parameters, and that makes the advanced reasoning viable on a modest hardware without a massive compute budget. Next, I will talk about the limitations. Okay, of course, there are some caverns. The approach still struggle with a function cell, a smooth dialogue flow, and a multilingual reasoning. And as with our RL system, reverse hacking and prompt sensitivity can trigger an unstable behaviors. That's all for my part. I will pass the slide to Yizao.
Hi, so now let me talk about the insights and also the significance of the DeepSeek R1. The paper actually highlights why DeepSeek R1 is such an important milestone for lately current AI research. So first, because of its autonomous reasoning developments. Well, DeepSeek R1 have actually proved that reinforcement learning can help large language models to develop their own logical step-by-step reasoning, rather than depending mostly on human-level data. Now, the model means that it can learn to solve the complex tasks by itself, moving towards a more faster, better AI. And second is about the significant cost reductions. According to the claims of DeepSeek, they only spent about $5.6 million rather than $100 or $200 million that's spent by other big companies like OpenAI, Cloud, Anthropic on their top previous AI model. This means a lot because now we're meaning Even though for the high level AI, it is actually using much cheaper price to train it, meaning it is much more accessible to everyone. And because of that, right now, efficiency is a new benchmark. With the major focus of efficiency, the industry now is starting to value not only just the performance, but also the efficiency. The goal is simple, to get the strong results with less computational cost. Actually, it will already change how the research just thinks about building AI and also benchmarking them. And finally, because of this R1, right now is actually broadening the AI people participation. Because of this lower cost and also the research that it needs, not only tech giants can only involve. Now, universities, new startup can also work on the most advanced AI at the same time. This broadened participations will actually help to move and speed up the innovation across the AI field, making the progress getting faster and faster. So in short, DeepSeek R1 is actually shifting the conversations in AI to include both high performance as the new baseline, very high performance, and also high efficiency, making the technology more accessible and better and smarter. With all that, thank you very much for your time. That's all from us.